And basically, this whole section has been about the topic of circles. And when we started this, basically, we've been learning a whole bunch of facts about circles. And the fancy word for facts about circles is actually just theorems. And the theorems that we've been learning, or the facts we've been learning, they kind of fall into three categories. They are the theorems that deal with the center of the circle. Then there are the theorems, that deal with something called cyclic quadrilaterals. And a cyclic quadrilateral is a quadrilateral where its corner points are on the edge of a circle. So that is called a cyclic quad. Now, today in the lesson, what's going to happen is we are going to talk about the last category of things. Why is my... Okay, I'm going to quickly go onto the next page. Nope. Okay, let me restart it for a second. For some reason, the screen is not happy. Let me close that. Oh, there we go. It caught up. Can I move? There we go. Sorry, guys. You know this is live when the teacher is doing this. Come there. Let's go. I'll make this go away. Just I can move down. I'll be with you in a second. There we go. All right. So the last category, or the last things of facts about circles we're going to be learning about, is something called tangents. Now, a tangent is a line that touches a circle in only one point, and that is called the point of tangency. So that would be a tangent, but there could be another tangent coming past the circle, and then that would also be a point of tangency. Now, if a line cuts a circle in two places, it's not called a tangent. It's got another word we use. And if you remember back to the very first lesson, we used that word. So who can tell me the word for a line that cuts a circle in two places? The line isn't just a chord. A chord, just in case you're unfamiliar, a chord is a line that goes from one point on the circumference to another. That would be a chord. Aha, yes, this is called a secant. All right, so the main focus of today's lesson is going to be around tangents and the facts about circles that tangents tend to go with and that we need to know. So I have a fancy little GeoGebra applet that I want to show you, and you can see the very first fact that we're going to learn about. And this fact or theorem is called the tan radius theorem. And as you can imagine, it involves the tangent and the radius. Now, if you look at the radius, it goes from the center of the circle to the circumference, and then the tangent meets it there. And what you'll notice is that if you move this point of tangency around, look at the angle that the radius makes with a tangent. It doesn't change no matter how big or how small the circle is. The tangent and the radius are always going to be perpendicular to each other. So whenever we see this T shape, we know that the angle between the radius and the tangent is 90 degrees, and we call that fact or theorem the tan radius theorem. We're going to focus on reasons a little bit more from now on, but the main idea still is to just for now understand the fact. Okay, so that's the first fact from today. The second fact for today is going to be what's called tangents from a common point. So let's give it a moment. If you have a point outside the circle like this, so you can see this point over here and this point over here, I'll even use my little pen. So there's a point and there's a point. There, if we look at this point, I'm going to move it around. Looks a bit like chopsticks, doesn't it? You'll notice that tangents from a common point to a circle have the same length. And the reason this works, a lot of these facts mainly come from congruency. But for the moment, all we need to do is just realize that if we have tangents from a common point, then those two tangents, they're both 125 in this case. If I move them closer, they will get shorter, but they still stay the same. And so that's called tangents from a common point. So let me actually do, before I show you the third one, let's actually do a question like based around this. No, is that one? No. Okay, let me jump to the next page. So I'm going to put one question on the board. And what I want you to do, the question is as follows. You're given a drawing with a circle. And then you're also given these unknown angles like 4A and A. You have to work out for me what the value of A is using this new fact that I've just given you, this new theorem about tangents and circles. So I'm going to let you figure that out for me. And then I'd like you to put the answer in the chat once you've got the answer. But I'm going to give you 2 minutes to do that. So you've got from there to that. And then please put the answer in the chat. What is A going to be in this circle drawing? Now, there are other shapes in the drawing. There's also, well, I'm not going to give it away, but there are other shapes that you also know things about. Okay, so Nizole, at the beginning of today, I made a comment that in a circle, if you have a tangent to a circle, that tangent will always have a relationship with the radius of the circle, a certain relationship. Now, in addition to that, that relationship is present in question 1. But there's also a triangle in question 1. And I want you to use those 2 bits of information to try and figure out what A is. I hope that helps a little bit. For those who are feeling on fire, I will let you try and do question 2. Question 2, you need to work out X and Y and Z. Although I actually may, see if you can do number 2. It might be a little bit too much now, but I'll give you the challenge while I explain question 1. Okay, so the main thing in question 1 is to realize there's something special about this angle over here. So angle OBC is going to be 90 degrees because of that fact I just told you. If you want to use the fancy word, it's called the tan radius theorem. But for now, I just want it to be 90. Now, the other thing that we know is we know that all triangles, and this is a triangle, adds up to 180. And so how do we use those 2 bits of information together? Well, I think that we can say that 4A plus 90 is 180. Sum of angles in triangle. And then we know 5A plus 90 is 180.
Sorry, sir. Students. There we go.
So, if possible, if you know who it is. Okay, so we got 5A is 90, and then we divide both sides by 5, and then we're going to get A is 18 degrees. So for the first one, A is indeed 18 degrees. Okay. Are there questions or comments? Okay, then let's look at number 2. But I think some of you will still be a bit uncertain. Let's see if this is, my pen is definitely being worse behaved than normal today. No why. Okay, In the second one, I haven't seen any answers yet, and so I just want to give a little bit more time before I do anything. I don't know why my pen is being so difficult today. Wow. Anything? Nope. Okay. In this question, y is 90. Aha, I don't think y is 90. Z plus y is 90. So Z is 40. Okay, now you're onto something. So I want to point out, guys, that OB and OD are both radii. And what can that help you with in that question? I'm going to give you a bit more time. The answers are starting to come through. Oh, why am I? Pen is being so difficult. So how can you use the fact that you have radii here? I'm just going to unplug my thing for a second. Okay, so if we look at this, we have to work out in question 2 what x is, what y is, and what z is. And there's a lot of detail and clutter. So if initially we have to decide where do we actually start in this question. And I want to suggest that figuring out y would be the quickest way to do this. Because in this drawing, if you've been with us since the beginning, you'll know that radii give us isosceles triangles. And so if you know that that side is equal to that side, what does y have to be? Well, you know in total that basically this and this will have to be the same because it's an isosceles triangle. And so you would say 2y plus 50 is 180. And then you would say, take away 50 from both sides. So you get 130. And then you divide both sides by 2, and you would get 65 degrees for y. Now, I see a hand up for a question. Catherine, I know a lot of you are probably finding this a bit tricky. What was your question? Do you want to ask your question? Okay. If you now know that y is 65, then I want to point out that this line here is a tangent. What do you know about the relationship between the tangent and the center of the circle? Can you use that to help you find z? So I'll look at the chat now. I see people have got z is 25. Where does the 2y come from, sir? Okay. The 2y comes from the isosceles triangle, Catherine. So if you think about this here being a radii and this here being a radii, then these base angles of this triangle, these two are both going to be y because these two sides are equal. So then what I said was I was going to add up these three angles, y plus 50. So maybe I should write this rather as y plus 50. And that came from that. Then I said, I know this angle over here is 90, which means that z would have to be 90 minus 65, which is 25 degrees. Okay, what's the last one we have to work out? We have to work out this one over here. X. Does anybody else have X? Well, I was thinking, isn't this thing a big triangle? And you know, Z plus Y, well, that's 90. So this angle here is 90. We know this one is 50. So X is going to have to be whatever gets me to 180, which is going to be 40. And so X is going to be 40. Now, I've kind of jumped right in today. And so I want to get a feel for the group. If you're feeling horribly confused, thumbs down. If you're feeling okay with this, thumbs up. And I suspect a lot of people won't be that confident yet because they haven't been at previous lessons. But let's just see what the floor says. And I can gauge my pace from that point.
Sir,
Yes.
while we're waiting for those to come in, can I just mention something here if you don't mind?
Please go ahead. Yeah.
Right. So even if this is like your fourth or fifth or 100th lesson of Watobe and you still find these a bit troublesome, or even if you're new, it doesn't really matter and you struggle with these, nothing stops you to go access the previous lessons that are recorded on the Watobe site. Yeah. Okay. You just go navigate to your grade and then you'll see all the previous lessons are there as well. Because now it gets overwhelming because now we start combining a few theorems together. And then some of us tend to hit a bit of a blank. So it's a good refresher to watch the previous lessons. All right, back to you, sir.
So I actually just want to do a quick little recap of the ideas. Because I think today you're going to see combinations happening. So some of the ideas that we use again and again are that a triangle is always going to add up to 180 degrees. That comes up a lot. The other thing that's going to come up quite a lot is that if you have two radii forming a triangle, two of the sides will be equal, which means the base angles will also be equal. And so you'll see people who using that idea a lot. Okay, so that's just a recap of some of the ideas. The other idea that will come up or may come up from time to time is that if you have 2 points on the circumference and you make an angle at the center and you make an angle at the circumference, this sort of arrowhead shape, this angle will always be twice as big as that angle. So that is going to come up, or it may come up because we've been doing it previously. And then the other thing is we're adding some new ideas today. And so that new idea, I just want to kind of emphasize it. If we have a tangent, it doesn't look like a tangent because it looks like it's missing it. So maybe I should. If I have that, and I have a line coming to the center, we know with circles, well, from what I showed you, that this is always going to be at 90 degrees. It's going to be perpendicular, which is going to be an important idea for today. So that's one thing I want you to keep in mind. The other thing I want you to keep in mind is if you have a tangent from a common point. Zoom in. If you have tangents from a common point, these are going to be equal. And if they're equal, and if these sides are joined and make a triangle, then that is going to form its own isosceles triangle as well. So I'll show you this again in the GeoGebra stuff that I was doing earlier on. If I can get rid of this. There we go. Let's just have a look at these ideas, because these are going to be the foundation. This is all we're going to do today is work with these tangent theorems, or facts, like I like to call them. So if I take this tangent and I drag it around the circle, notice how it's always at 90 degrees to the radius. And so we're going to use that fact to help us solve problems. Then the other one is this tangent from a common point, which is the same idea. It looks a bit to me like chopsticks, like you're trying to eat food with like a. And so that idea is going to be constant throughout. And then I'm going to add one more to that. But before we can do that, let me try and rather practice questions that just use those two for you. If I can find some, let's have a look. look. All of these around that. Now this look a bit scary. No, let me go back to here. All of these involve, okay, I've got to show you this one other theorem, and then we can get to the main ideas. All my examples have it involved in some degree. Okay, say that we have, there's one more situation I want to deal with. Say I have a circle like this, and the tangent comes along like that. Sure, sometimes I will have a line going to the center, but sometimes I won't. Sometimes I'll only have a line coming across like this. And this angle here, this thing over here is called a chord. This thing over here is called a tangent. And we call this the angle between the tangent and the chord. Okay, so that's the first little bit. Now, if I then take this chord and I build another angle. Now, I know this is a bit strange, so hang in there. And then if I take that chord and the fancy word is I subtend an angle at the circumference of the circle, then these two angles will be equal. It's kind of weird when you think about it. And this is called the tan chord theorem. Another way of seeing it is to see it from the other side. So if I have this angle over here, if you imagine the angle between the tangent and this chord, then those two angles are going to be equal. Okay, so that is a bit strange, but let's just see it in the GeoGebra thing. And then we'll take these ideas and we'll explore them further. So I'm going to play with my tangents here. And notice how the angle, the 65 over here, is an angle between the tangent and the chord. And then that chord makes an angle at the edge of the circle. And those two are equal. Then on the other side, we have the 58, which has its matching pair. And this is called the tan chord theorem because it's between the tangent and a chord. Now, it's much easier if I just show you. It's a bit hard. Let's look at a question where we get to use this idea. Let's look at 5. I want you to work out what is the value of angle H. So angle H, this is the angle here. Using this new fact, I want you to write in the chat, what is H going to be equal to? Just using what I said in the last lesson, in the last comment, basically. I know I spoke a lot there, so just see what you can do there. Okay, yes, Taylor. Is indeed going to be 70. David, it's also going to be 70 because this tangent and this chord are going to make an angle, and they are going to be the same as this one over here. Sometimes this is called the windsurfer theorem because it looks a bit like a windsurfer. And so you're quite correct that that is 70 degrees. So H is equal to 70. Now, I want to know what is K going to be equal to? Now, remember, you've got these two whiskers here. Now, what do they mean? And can they help you find what K is? So I want you to put in the chat, what is this K value going to be equal to? Yes. Okay, a lot of you have got this. So let me explain why that is. Because these two whiskers are here, it means that this and this must be equal. They're 70 and 70. This thing is a triangle, which means in total, this must be 40. And so K is 40 degrees. Okay, now the last thing. I want to know what is the angle I down here hiding in the corner. I want you to think, what are the 3 facts about tangents that we've done today so far? And which one does this most look like? Does it look like chopsticks? Does it look like a windsurfer? Or does it look like a T? Okay, I see some answers coming in. Give you a little bit more time. Oh. So I think there's a relationship between, I think these are tangents from a common point. And if these two are equal, what that means is that that must be 70, which then means I must be 40. Okay, so now we've basically used those 3 new facts well, 2 of them to help us solve this problem. And that's all I want to do today. That's the whole goal of today. So let's do one more before we take a break. Let me not do that one. Let me choose number 6. So I want you to try and work out the answers for M and for N. So those are the 2 things you need to find. You need to find the angle M and the angle N. And I want you to use the facts that you've learned so far today. Again, a fancy word for facts is theorems. We are using facts about circles and tangents. In this question 6, I can see 2 tangent lines because these lines are touching the circle in one place only. But I don't want to give more than that away. But what I would like to know is what is this angle and what is that angle there, called M and N. I leave them to you for now. Ms. Anya, I've been quite involved in my teaching. Is there anything that I've missed in the chat, or students that seem like they're kind of catching along here?
They are getting along. In fact, we actually have a comment from Sarah saying that now she understands a bit more. So there's brilliant. Bali just asked now, where's the 32? So if you look there, it's Bali, it's angle QPS, so it's highlighting now.
Yeah. So it's a little bit kind of, maybe I'll zoom in a little bit more so you can see it better. If I can, I can't get much bigger. But the 32 is this bit here. Now I'll give you one little tip. Angles on a straight line add up to 180 degrees. And that can always be a useful fact. Like back in grade 8 or 9, we learned that angles on a straight line add up to 180 degrees. Maybe we can use that. Okay, so the first answer that's come in is M is 100. I don't know if it's right yet. I haven't worked it out, but let's keep those answers coming. And then also an answer for N. Okay. So M, there's also answers of 108 that might be true. We don't know yet. What I do think I can work out is I think I can work out what that angle over there is, because I know that this is 40 and that's 32. And that might be helpful. So I think 40 and 32 give me 72, which mean that this is 108 degrees. Now, just make sure I've got that right. I have got 108. This angle over here is the angle between the tan and the chord, tangent and the chord. And then this chord makes this angle over here, which means those 2 must be equal. That one and that one have to be equal. And that's still quite tricky. M is 108. Now, if M is 108, can I now work out what, so I've got what M is. What about N? I think this is going to be the isosceles triangle thing. I think that for N, this, oh, sorry guys, this is a triangle, but two of the parts of the triangle are tangents from an equal point. And so I know that these two over here, so this angle and this angle must be the same. And I know that that one's 72, which means this one over here must also be 72. So now all I need to do is take my two lots of 72 and work out what N is. Okay. Nizola, I'll get back to you in a moment. So yeah.
Just again, do you mind just explaining to the students why the green triangle that you've drawn, why those tangents are equal? I know you mentioned at the start of the lesson, but maybe just remind them.
Okay, so here is the point Q, and look at how it is on a tangent line. It just touches the circle in one place. But this point Q also, so we say these are tangents from a common point. So we know that these are going to be equal. Tangents from a common point have two lines that are exactly the same. If we go back for a second to, here it is. If you look at the line 106, look at how it's got a matching partner below. And how if I move this, let's see if I can move this. It always matches, they're always of equal length. So that's what I'm using. So if that's the case, this must be an isosceles triangle, which allows me to say that in an isosceles triangle, this angle and this angle will be the same. Now to go back to another point, how did I get 108? Well, this angle, first of all, I had to get that this angle on a straight line is 180. And so I said 180 minus 40 minus 32, which are down here, gives me 108. So let's get rid of that. So this is 108. The real clever bit is the connection between this tangent and this chord. And the angle between the tangent and the chord, we say, is always equal to the angle in the alternate segment. Now that's a little bit too many big words for one day, but essentially the one segment of the circle is this side. The other segment is on the other side of the chord. And so the angle involved here is going to be over here is going to be 108. So I hope that helps a little bit. If we practice this more, it will become easier. Then how do I get what N is? Well, I say this is 72, so this must be 72. And so N must just be 180 minus 72 minus 72, which is going to give me, I think, 36. Okay. Give us a thumbs up if you're feeling okay. Give us a thumbs down. I just want to get a good feel for how the group is feeling about this now. Again, don't be afraid to give us a thumbs down. I want honesty. You don't need to make me smile. I want absolute honesty. Okay. For those who are still feeling unsure, can I ask you, in fact, for everyone, let's do this question 7, where we have to find X and Y. And again, I want you to focus on the same basic facts. In fact, in this case, we only have one tangent involved. And when you do this question, I want you to think of the following shape. I want you to think of this shape over here. called the windsurfer. If you look at the windsurfer, you'll see that the angle between the tangent and the chord is equal to the angle in the alternate segment. But it can also happen from the other side. It can also be that, oh, sorry, guys. So I'm trying to show you that relationship. So I want you to think about that relationship in question 7 to try and find X and Y. So what angle will the X go with? So if you think of that tangent and that chord, what matching partner can I find in that? So in this question, this segment, this part of the circle is called the alternate segment. So the circle is divided into 2 parts. It's divided into the sort of the yellow side and the pink side by the chord. Now in this question, we say the angle between the tangent and the chord is equal to the angle in the alternate segment. And so in this question, X is going to be 50. Now, what is Y going to be equal to? There's actually 2 different ways you can do it. So the one way of doing it is to say, what is P? And P would just be 180 minus 50 minus 62, which is going to be 112, which is 78. Oh, is it? Maybe I made a mistake. I think I have made a mistake. It's 68, yeah. So 180 minus 62 minus 50, that's 112. And so that's going to be 68. So we would say this answer here, that's 68. And then we can look at the same thing. The angle between the tangent and the chord is going to be equal to the angle in, so basically these 2 are going to be buddies. And so Y would be equal to 68. Or if you are really sneaky, you would have said angles on a straight line add up to 180. And so 50 plus 62 plus what gives me 180. And to do that, you would have just said 180 minus 50 minus 62, which would give us 68. Okay, so now that we're starting to get this, let's keep going and do number 8. So I want you to try and do number 8, and you're going to try and find for me A and B. Try and find A and B. And I know for those who have been here since the beginning, you know that we are now making it, like things are getting decent. So just go step by step. What is A? What is B? Given what you've learned today, what relationships are there? While you do that, I'm going to get some water. Miss Anya, from your side, anything that you notice or want to chime in on?
Just the biggest thing, and I've mentioned this before, I think a lot of our students, whether you're new or old, will need to revisit some of the previous lessons as well. Because as I said previously, the moment we combine, it's as if it's just too much and then we just hit a blank. And you must just go back to basics. And what I suggest is make some time and try to summarize all the theorems. So like all the facts, as Sir likes to call them. Try to summarize all the facts on one page. So when you do these, then you have like a little, I don't want to call it a crypt note because obviously you're not allowed that in an exam, but have that next to you so that later on it starts becoming like memory to you.
Exactly. Yeah. No, I think what I'm trying to do in this course is introduce you to the main ideas of circle geometry. Once your brain has had a chance to digest those main ideas, you can then start to mix the ingredients together. But initially, you have to give yourself time just to get used to the shapes, like we said, the windsurfer, or the I call them chopsticks, but like you have to kind of first get those shapes into your head. And a good way of doing it is just drawing out the theorems yourself and making a summary, like Ms. Anya was saying. Okay, let's have a look here on number 8. What answers are coming through so far? So lots of 32s and 74s. Let's have a look. You know what else works really well, guys, is using colors. So even when I start this question, my brain is a little bit like, And so I'm gonna say, well, here's the tangent, and it makes this angle with the chord. Now, where's that 74 going to be related to? It's going to actually be that angle over there, that big red dot. Sorry, that's a bit huge, isn't it? So it's going to be that one there. Now, that isn't what we wanted, but just by knowing that 74, it can help us. And the reason it can help us is these two whiskers over here. These two whiskers allow us to know that those are base angles of an isosceles triangle. And so A must be 74 degrees. Now, from there, because they're both 74, we then know that this one up here must be, they must add up to 180. So I just think I'm going to go 180 minus 74 minus 74. And what am I left with? So 140, 148, you should get 32. And that's going to be the answer. So A is 74 and B is going to be 32. Again, let's have another vote. Show of hands. Who is feeling more comfortable now, or who's feeling comfortable? Who is not feeling comfortable? Vote in the chat. And Ms. Anya, if you could just get a sense of the of what's going on.
Will do.
We're going to do 2 more questions, I think. Number 9 and number 10. And number 9, you have to find the value of E. For number 10, you have to find M and K. And I want you to just start by thinking about how can this shape maybe help me? And then also go back into your grade 9 memory and go, what is this funny arrow? What does that mean? And then once you've got your answer, put it in the chat. Let's see what you've got. And then do the same thing to the other one. Draw in the shapes you notice. What have you got? Let that help you. So I think that is code for parallel lines. And I remember from grade 9 geometry, parallel lines is something called alternate angles. And alternate angles are actually equal to each other. So maybe that can help me in this question. Okay, Kitty Bona has already got stuff. Kuluso, Dudu's answers are coming through. I don't know if they're correct yet, guys. So I'm going to wait a bit longer for everyone to submit their answers. But there are some answers coming through at this stage. I think this one over here is going to be E, because these are, it's the Z shape. And then Loago, your hand is raised. There we go. So if that is E, now what are the other shapes we need to know? I think that from the That's the angle between the tangent and the chord. That's the angle in the alternate segment. That is going to be E, and that's going to be E. And so together we have E plus 3E equals 180. 5E is 180. I divide both sides by 5, and I think I get E is 36 degrees. Okay, so look at that carefully. How did I get those things? The 1E came from, oopsie daisy. The very first E came from the relationship between here and here, and that's the alternate angles. And then the other relationship came from the, I call it the wind surface shape, where this angle and this angle are equal. And now I have that there, and I have this, and then the 3E was there all along. And so that's how I got my 5E, adding up to 180. As long as I don't make a mistake, I'm good there. Okay, last question for the day, and it has been a top training session today. This has been proper, here's some new ideas, interpret them into circle geometry. I'm just going to draw some pretty pictures first. So I know, even though it doesn't help me yet, I know that there's a relationship between this one and this one. And there's also going to be a relationship between that one and that one. I'm going to use all my colors today. That's a bit big. So how can I use those pairs? The only angle I've got is this 54 down here. Okay, so I'm going to try and get K first. I think that there's also, this is a tangent from a common point, which means these two sides are equal, which means this angle and this angle is going to be equal. And I know that that triangle must add up to 180. So I'm going to remove the 54 and see what I get. I get 131.26. But that 126 needs to be shared between two angles. So I'm going to divide 126 by 2, and I get 63. So K is 63, and that is 63. So I've got that using isosceles triangle and tangents from, this is called tangents from a common point. So there's my one tangent, there's my other, and it makes an isosceles triangle. Now what I need to find is I need to find what this M is down here. And there are some answers coming through. How am I going to do this? I think that this D up here has to be 63 because this angle over here. Now, there could be other easier ways to do this that I'm not seeing, but I see that relationship. I then know that that is 63 because these two whiskers, well, I call them whiskers. I shouldn't really call them whiskers here. I'm not a vet. These two equal lines or equal sides of a triangle are there, which means the base angles are equal. So now to work out what M is, I just need to take away 180 minus 63 minus 63, which, if my maths is correct, is take away 126, which then gets me left with 54. Aha. Yes, I see my people are winning. Okay, guys, today has been a tough lesson because I just want to go over the three main ideas that we covered today. We covered that when we have a tangent to a circle and a line to the radius to that tangent, that will be at 90 degrees. So that was the one thing we did today. The other thing we did today, or other fact or theorem that we used, is if we have a tangent from a common point, okay, we'll call that common point D, then those two sides will be equal, and they'll often form an isosceles triangle. And then the last thing we did today was if we have a tangent, and that tangent has a chord that makes an angle with that tangent, then there's a relationship between the angle that chord forms. So we would say this angle and this angle are going to be equal. And what's more, we would also have from the other side, this angle here and this angle here will be equal. And so this is called the tan radius fact or tan radius theorem. This is called tangents from a common point. And this is called the tan chord fact, which we will use them in future lessons. So what I want to do now is I want Miss Anya, if you could just put a poll out of this time, the 1 to 4 poll, the poll which is how have the students found the lesson today from 1 to 4. First, I want to do that poll.
Okay.
And then I just want to get a feel for how, if we were going too fast today or not.
And then I've also, while they're completing that poll, sir, I've also set up a poll for the topics.
Perfect. So guys, don't go off yet. We're going to do one more poll after this, just so that we have a sense of how you're finding this lesson. We try our best to adapt for the group, but often it's helpful to get the polls for us to know how you're really feeling and being honest. Okay. So, and then while those polls are going on, there are 2 raised hands. I will try and answer questions. So, Nosisa, if you could go ahead and unmute yourself. Nosisa, do you have a question?
Yes.
Yes.
I actually would like if we did something like a sum or something, we would like use reasons on the side.
Okay. The good news is the next lessons, there's reasons for 8, 9, and 10. We are going to be using the reasons. Okay. So the only reason we haven't been using reasons is that I found that students find it overwhelming if they do too much at once. And so I really deliberately wanted to I wanted us to get to know all the facts first before we started to use reasons. So that was my thinking, but it is definitely coming to a place near you. I see that the first poll is done. The second poll asks you, what are the topics you basically have covered at school so far this year already? And that just helps us plan for going forward so that we can try and offer you lessons that are as close to what you're doing at school at the moment as possible. And then Ms. Anya, if you could just take screenshots of whatever polls are coming up, please too.
I have screenshot of the other one